Hello, my name is Natawi Sifar and today I'm going to present about Ventilator project. In 2019, there is a COVID infection, which is COVID-19. It is a respiratory infection caused by the new coronavirus that is known as SARS-CoV-2, which enters your airways and can make your breathing difficult. COVID is widely spread and ventilator is needed. Ventilator helps you take breath if you can do it on your own. However, it is very expensive and high demand. So, emergency ventilator is invented. What is a ventilator? Ventilator is a machine that helps your lung work. It helps to push air in and out of your lungs so your body can get the oxygen it needs. A doctor or a respiratory therapist will control the ventilator. Now we're going to focus on respiratory system. Respiratory system is a network of organs and tissues that helps you breathe. The respiratory system has many different parts that works together to help you breathe. Each group of parts has many separate components. There are mouth and nose, sinus, pharynx or throat, trachea, bronchi tubes, lungs, and alveoli. These parts work together to move oxygen throughout the body and clean out waste gas like carbon dioxide. Mechanism of a ventilator. A pulmonary ventilator referred to as breathing. It is the process of air flowing into the lungs during inspiration or inhalation and out of the lung during expiration or exhalation. Air flows because of the pressure difference between the atmosphere and the gas inside the lungs. Next, respiratory volume and capacities. Respiratory volume is an air moved by lungs at a given point in the respiratory cycle. Consists of inspiratory capacities, expiratory reserve volumes, or the amount of air forcefully exhaled past the tidal volume, residual volume, or the air left in lungs, of vital capacities, inspiratory reserve volumes, or the deep inhalations, and the tidal volume, which is the amount of air enter lungs during a quiet breathing. This demonstrates the ventilation graph of a common ventilator mode. For volume control, the pressure increases linearly, and the volume also increases linearly until it reaches the tidal volume, and the flow is constant. And for pressure control, pressure is constant to the pressure limit, and the volume is increased depends on pressure, also to the flow. We will focus on two modes of ventilator, CMV and AMV. CMV is the controlled mode and the AMV is the assist mode. Components. We need adapter 24 volts, Arduino, self-inflating bag, bolts and nuts, motor, trigger sensor, ESP and pressure sensor. For the software, we use Arduino for coding and use Blink to control the ventilator. Firstly, we will define the header of the Blink, and then we will define the template of the Blink we connect. Then we include the header and insert the token of the Blink application, and then we will set a password for the network and the timer. Then we will determine the integers of each variable and set up the time for the Blink to connect, and also connects the pin of the Blink and the code Arduino, which will be V10, V12, V11, V14. Then for void setup, we will debug the console by 9600. And then for void loop, we will run the ventilator. And then we will send package, which is A, B, C, D, and E. Then these package will be sent to the Arduino code. Firstly, we will include the header for Arduino and breath sensor or the pressure sensor, and then we will set up the serial for ESP and the pin of the sensor. Then we will scale the pressure sensor and then determine the pin of the motor, which is 12 and 11, and then the pin 5 and 7, also the bell. Next, we will determine the integer of each variables. Then we will set up the zero pin and time and pull up and pull down of the ventilator, and then we will go to the void loop for it to routines and run over again. Then it will go to the ventilator run that set the speed of the zero pin and max pin, and also the ventilator stop. Also for the assist mode, it will be set up as the void assist mode, and then the integer for the BPM ratio and the expire time, also the BPM. Then it will receive a package from ESP, and then it will run the code as follows. These are the data that it will read and receive from the ESP. And then this will be shown in the serial print to determine the data received from the ESP. And this is the case for the IE ratio to be controlled on the Link application. And lastly, the serial pin of BPM, D1, and read data.